The life sciences industry is in the middle of a frenzy of merger and acquisition activity. So, for example, Merck's recent purchase of Cubist is typical in that it's aimed at getting hold of some very important differentiating capabilities, in this case in antibiotic resistance. It looks like a good move, but careful consideration of how evolution works suggests that deals of this kind may be necessary but not sufficient. Let me make a diversion into the theory before I return to the practical points to take away. You'll recall, I'm sure, that one of the big surprises of the Human Genome Project was that about 98% of our DNA was non-coding. This was quickly labelled junk DNA by the popular press. And researchers continued into exactly how much of this DNA is useful and what it does. However, we know that some of it performs the important role of switching coding genes on and off. And very important this function is too. Work looking at the Galapagos finches, for example, whose variation famously inspired Darwin, showed that the coding genes of the different species are very similar indeed. Their beak and the other phenotypic variations are caused mostly by those same genes being switched on and off at different times during embryonic development. Junk DNA, in this case, is far from useless and makes all the difference. Now, in my research into the evolutionary mechanisms of the life science sector, the analogues of genes are organisational routines which express themselves as capabilities, the analogues of proteins. And we can class capabilities into one of three types. Firstly, core capabilities, or that's those that are necessary just to operate in a market, such as legal compliance. Secondly, differentiating capabilities, which are those that can create competitive advantage. So for instance, the ability to create compelling health economic value propositions, for example. However, both of these very obvious capabilities are equivalent to proteins expressed by coding genes. They lead directly to some observable trait of the company. The organisational analogue of the less obviously useful genetic switches is an organisational routine that leads to a third type of capability known as dynamic capabilities. Dynamic capabilities enable the organisation to shift or transform its assets or resources. So, for example, the capability to create true market insight is a dynamic capability because it enables resources to be reallocated. Similarly, the capability to make cross-functional teams work is a dynamic capability that is necessary to switch on and off many differentiating capabilities, such as key account management or brand management. So to draw the biological analogy a little further, some routines in a company express themselves visibly via core and differentiating capabilities. Other routines, however, look like junk on the surface, but turn out to have vitally important roles in reshaping our assets and resources. So how is this relevant to our industry's spasm of acquisition and licensing? Well, each of those deals is a kind of gene transfer. Typically, firms are trying to acquire a set of organisational routines for discovery and development of a new technology, such as in Merck's case. Yet there appears to be a set of genes, that is, organisational routines, that firms need but aren't on their acquisition list. Those are those that lead to dynamic capabilities such as routines for change management, cross-functional working and other less explicit capabilities. Of course, the big firms might have these already, but in my experience that is often not the case. And one wouldn't expect the relatively stable environments in which big pharma has lived for decades to have favoured routines that enable change. If I can make another slightly less serious analogy, it is as if the big firms are trying to make themselves attractive by acquiring genes for height and blonde hair and blue eyes and low body fat, whilst ignoring the genes for intelligence and adaptability and learning ability. If you'd followed my perhaps tortuous analogies, then the practical implications might seem obvious. Big Pharma currently identifies those differentiating capabilities it is short of, such as those in some specialised area of R&D, and goes out to buy them. But the dynamic capabilities idea suggests that this isn't enough. They also need to consider their abilities to learn and understand the market and change management, and finding ways to acquire those routines. And if you think that this is an abstract theoretical issue, just think for a moment. How good is the average big life sciences company in any given area of R&D? Typically the answer is pretty good. But how good in comparison are these big companies in making change happen across functional boundaries? To take just one example. Typically the answer is rather less good. The moral is that in attempting to adapt to a changing environment, it may be necessary to engineer the firm's coding DNA, but it's also just as important to pay attention to the junk DNA.